Hey everyone, hope you're doing well. In this tutorial, we will go through a complete e-commerce database development. First, we will assume the client requirements for the database. Then we will clarify the rules on how to draw the ERD. Then we will draw it. After that, we're going to convert the ERD to a relational schema. And we will describe briefly the rules of this conversion. Then, using SQL language, we will discuss all the CRUD operations. Then we will build our database using SQL. Lastly, we will illustrate how we can use interfaces to control our database using a simple Windows form, like searching for products or updating an order to the database. I want to emphasize that we will discuss and explain in detail the rules of each phase in this development, not just making the practical part for our project. So at the end of this video, I hope you will have a solid overview on how to create a database. This video also is divided into sections so you can navigate to the specific part you need. All the tools that I have used in this video will be down below in the description so you can check them. And without any further ado, let's get started. So before assuming our requirements for the database, we should know that the bottom line of the database that it carries data about a certain area, we call it a mini world. This data is in form of tables that we can do operations and queries on it. So in our case, for an e-commerce database, we can assume these tables. First, customer table that has the following columns or attributes, like customer ID, name, email and password, and addresses for this customer. The second table we must have is product table, and this can holds product ID, product name, price, and image for the product. And also we must have order table that has order ID, order price, and status for this order, like delivered, not delivered, shipped. The fourth table we can have is payment table that has the payment ID and payment method and the status for this payment, like paid, not paid, partially paid. The last table we can have is shipping table that has shipping ID, shipping address, and shipping status. And also we have necessary relationships we must assume, like customer can make an order, and each customer's order has a date, and order have products, and order will be shipped, and order will be paid. So this is all for this simple section. Let's see in the next sections how we can meet these requirements. The second part of this video will be how to draw the ERD. The ERD is a graphical way to show the tables of the DB and their attributes and the relationships. Before we draw the ERD for our project, we will explain some concepts and symbols we need. Then we will apply this in our project. These are the symbols we use to draw the ERD. First, we represent table as a rectangle in ERDs, and from each rectangle, we draw a line to each attribute in an oval shape. For example, we have here the product table and their attributes. Second thing, we should know that each table has something called primary key. And primary key is very important attribute in databases, and it is a column or attribute that cannot be repeated for more than one row or record in the same table. To distinguish this attribute, we put a line under it. The primary key can also be more than one attribute. Like if we have a table for borrowed books, the primary key in this table cannot be the student ID only because he can borrow more than one time a day. So we add the date and the name of the book to the primary key, and we call it a composite primary key. The next symbol is the overlapping symbol here, and it carries the multi-valued attributes. Like the addresses of the customer in our project, we put it in overlapping ovals like this. And if we have composite attribute, we draw a line to each part. Like the name of the customer, it is divided to first name and last name. And about the weak entity symbol, it is an entity that depends on another entity. In our project, the payment entity is a weak entity because it depends on the order table. There is no payments without orders. And about the relationships in databases, we should be aware of two concepts. First one is the cardinality. It is for one row of a table, how many rows of the other table can be linked to it. For example, for an order, how many customers in the customer table can be linked to this order. It is one customer that can make that order, and we will see how we can represent this in ERDs. And the second concept is modality. It describes for two tables if each instance of the both sides of the relationship must involve in this relationship or not. So for example, in the customer order relationship, is it must that each customer has to make an order, or it can be customers without orders? Yes, it can be a customer without orders. So it's about acceptance for null or zeros. And both concepts will be so easy after we explain them in our project. We represent the relationship in diamond shape. We can name it make. Then we link between them. But for the cardinality, we see for one customer how many orders can be linked to it. One customer can make many orders, so we put M in the side of orders. So we can drag the many line from here. For one order, how many customers can make that order? It is one customer can make the order. So we can drag the one line and place it here. And now for modality, is it a must that each order be linked to a customer? Yes, it is a must. So we represent this with two lines. In the side of order, each order must be linked to a customer. And for the customer side, is it a must that each customer be linked to an order? No, there can be customers without orders. So we represent this with one line like this. And now for product order relationship, for the modality part, is it a must that each product be in an order? No, there can be products not in any order, so we call it partial relationship in the side of products. And is it a must that each order has products? Yes, it can be no order without products, so we call it in the side of order total relationship. And for the cardinality part, for one product, how many orders can be in it? Many orders can contain the same product, so in the side of order we put many. And for one order, how many products can link to it? An order may have a lot of products, so we put many here also. We change the symbol of it to represent that is not necessary to be the same quantity. And for the relationship between order and payments and order and shippings, for the cardinality part, order may not be paid yet, so each instance of order table may not be linked to payments table. And for payments, it's must to be linked to an order. And for modality, for one order, how many payments can be linked to it? It's one payment, so we put one here. And for the payment, how many orders can be linked to it? It's one order also. And for the shipping, we will be the same. If we follow these rules, the relationship will be the same as pay relationship. So this is all for the relationship part. And to recap the relationships part, we can see here that there is one-to-many, many-to-many, or one-to-one relationships. And we can understand also the modality here for the total participation or partial participation. And after we ask the both questions for each relation, we can construct the correct choice for both concepts. Let's see how we can map this ERD to a relational schema. Mapping is the rules we follow to construct the relational schema. And the relational schema is the nearest form of our real database. It illustrates more clearly how the database tables relate to each other. The first rule is we map strong entities, and strong entities are any entity that does not depend on another entity, or in other words, any entity that is not a weak entity. So we have three strong entities: customer entity and order entity and products entity. We will map all of them, and regarding the addresses multi-valued attribute, we will not map it because it has a separate rule. We will discuss it later. So we made three tables for the three strong entities. We put the name of them at the top, then we add the attributes, and we put a line beneath the primary key. The second rule that we map the weak entities, we have two weak entities: shippings entity and payments entity, and there is no differences from mapping strong entities. Despite that, we must link the weak entity with the strong entity by placing the primary key of the strong entity in the weak entity as a foreign key. And foreign key is a new term we have, and it is a key we put in a table to reference another table. And this, as we will see, will help us a lot when it comes to SQL code when we want to link or join two tables to make queries or operations on them. Now we have mapped the basic attributes of the payment and shipping entities, and we want to link them to their strong entities. We will add an attribute to the payment. We can call it order ID. Then we can link it to the order ID here. And also for the shipping table, we want to link it to the order ID. So we add a column, can call it also order ID. So we linked them. The third rule in our hierarchy that we map one-to-one relationships. we put the foreign key in the total participation table. We have here order shippings relationship. Shippings is total participant in this relationship. So we put the foreign key of the order in the shippings table. Then we link it with the primary key of the order. So we put the foreign key of the order table in the shipping table, but because shipping is a weak entity, we have already linked it with order ID. And for the payments order relationship, it is also one-to-one relationship, and payments is a weak entity. So we have already linked the order ID with the order primary key here. The next rule that we map one-to-many relationships, and this is done by placing the foreign key in the many table. And the reason for this can be obvious if we look to these two tables. We need to reduce redundancy in the database because it can lead to join problems in SQL code. So here we put the foreign key in the orders table and we link it with the customer. And also in this relationship, we have the date attribute linked with the relationship itself. So we put it with the table that will take the foreign key. So we can also add date here. The next rule is we map many-to-many relationships, and for this we make a new table to reduce redundancy in the main tables. If we put them in the main database, we will need to repeat the same row more than one time. As we can see here, this row is repeated several times because the many attribute has several values. So to avoid this, we make a separate table for many-to-many relationships to make the repetition at the minimum level. And if we want to make a query of the whole table, we can join and make the queries on them. So we will add a new table here. Can drag him. Order ID. And also we have product ID. But both of them is part of the primary key. So we put a line under them and we link them with the main tables. Like this, we have the order ID linked with the order table and the product ID linked with the product table. The next rule is we map multi-valued attributes, and as the same concept of redundancy, we keep multi-valued attributes to map them in a new table. Let's name it customer addresses. We need the foreign key customer ID to link it with the main table, and we add the addresses here. And customer ID is the foreign key. Then we link this. And the last rule for mapping, which doesn't exist in our context, it is how to map n-ray relationships. And these are relationships between more than two entities. For example, if we look here, as we can see here, teacher teaches subject and student. In this case, we make a new table and put the primary key of each table. And this is how we can map the n-ray relationships. And also there are attributes on the relationship itself, we add them to the new table we will build. So these are all the rules for mapping. You can take a screenshot for them, and this form is the nearest form to our SQL code, and we will see in the next section how we can build the database using SQL only. The next section of our video will be how to create the database using SQL code and how to make CRUD operations. And CRUD operations are the basic operations that no system can be without them. The approach of this section will be as follows. We will build our tables from scratch using SQL, then we will insert some data and try to update a record, then delete it to include all CRUD operations. We will use SQL Server Management Studio, and I will leave link in the description that explain how to download it. And also I want to remember you that the code we will write is uploaded on the project repository in GitHub. And let's go. First we open SQL Server Management Studio. We choose the server name and authentication. We make it Windows authentication, and we must make trust server certificate checked. And after that we click connect. Here will appear the server name and databases checked section. If we click on the plus here, our databases will be appear. We right click on the databases and choose new database. Let's give our database a name, e-commerce YouTube. We click OK. The database we have just added will be appear here. We right click on it and select new query. In this space we will build our tables and make other operations like CRUD operations. First we will create the tables, then insert some data, and then make the operations. So our first table was customer. We follow this syntax to create tables. Create table, then we give the table name, customer, open braces, we give the attributes of the table. The first one is customer ID. The second one was first name and last name and password. char 50. Then we have email. Like this we create the basic attributes, but we need to make the customer ID as a primary key. So we write primary key beside it. And we want also when a new customer is added to the table to automatically increment the ID by 1. So we type identity and give the starting value of the IDs in general. Let's make it 1 and give the incrementing value. Let's make it 1 also. So here when a new customer is added, the next ID will be incremented by 1. This is all for the customer table. We do the same for the product table. Create table product. We have product ID, product name, and price and image. Price, decimal. We give the integer value or the integer digits and the digits after the floating point. Image, we store it in var binary. Var binary max can hold images to 2 gigabytes. Create order. But because order is a reserved word in SQL Server Management Studio, we must put it in square brackets. Order, price, status, date. The date, there is an variable type called date that holds the dates. The last attribute is a customer ID, and customer ID is a foreign key. So after we create it, we add references. Then we add the table name and the attribute we refer to. Customer. Here customer ID is referring to the customer ID in the customer table. The remaining tables have no differences from the tables we have just created. So to keep time, I will paste it. For now, we still didn't create any table. So to create the tables, we select all of them and click execute. So now if we click the e-commerce here and go to tables, we will find that all the tables we have created appears here. Now to insert data into these tables, we follow this syntax. Insert into, then we give the table name. We will insert into customer. Then we add values. Open braces. And we give the attributes of the customer table in the same order. Ali, Ahmed, password, let's make it 1 2 3 Ahmed. We should note that we didn't give the customer ID because it's auto incremented and have a starting value with 1. And if we want to give a specific values to a specific attributes, we could name it after the customer or the table name. So let's copy this line. If you paste it here, we can like add first name and password just like this, and just give the password and the now there is no error. And if we select these 2 lines and click execute, 2 rows are affected. So this is for insert. Now we can go to the second CRUD operation, which is read. We use for this operation a select keyword. We write select and we give the attributes we want to display. And if we want to display all the attributes, we write asterisk and give the word from and the table that we will use. We can execute this line. So now he displayed the values from the customer table. And if we want to display data with a certain condition, we can add the keyword where. Let's make the last name, for example, name equal Ahmed. So he gave us the records with last name is Ahmed. So this is the read operation. The next CRUD operation is update. We write it as follows: update. Then we give the name of the table we want to update, customer. Then we give the set reserved word. Then give the values of the attributes we want. First name equal A. Last name equal then we specify the factor upon which we want to make the change. Name equal the last CRUD operation is delete. We use it to delete a specific record on the table, not to delete the whole table. The syntax of this operation is so simple. We write delete from, then we give the table name, then we give the condition upon which we will delete where, last name equal so if we execute this query, one row affected. Now we deleted the second record. So this is all for the SQL code, and let's go to the next section. Finally, we will make a simple GUI that shows us how we can make changes to the database using an interface, which is in our case a Windows form. We will show how we can search for products and how we can make an order that will be added to the order table. First, we open Visual Studio, create a new project. We search for Windows form. We choose the one with C#. Let's name it e-commerce. GUI. Next. So when you open the project, the interface will be like this. In brief, in Windows Form app, you have a space here that you can drag and drop items from the toolbox. Then you can write a code in the background of them to make your items dynamic and interactive, as we will show on the rest of this video. First, we go to the toolbox. If it doesn't appear for you, you can go to View and select the toolbox from here. First, we want to get the items that we will use in our Windows form. We need 3 text box. One, two. And also we need labels. And we will need picture box and a label for it. And also we will need 2 buttons. And before we go to the code part, we want to style and arrange them a little. If we go to properties, we can change the background color from here. Let's make it this one. And if we choose the label, we can change the font color. Let's make it white. We want to name it what. Make it bigger. Search. Can change the font also. We need one more label. Change the font from here. After we finish the interface arrangement, we want to link the SQL Server to the WindowsForm app. So we go to Server Explorer, and if it doesn't appear, you can get it also from the View part. Where is it? Server Explorer here. And to add a new connection, we click this icon and search for the server name. We can get it from SQL Server. You will find the name here. Can copy it. Then make Trust Server Certificate checked and select the database from here, e-commerce YouTube. Then we click OK. Now we have linked the database with the WindowsForm app. If we right click on any item here, he will take us to this part. We can write the code of each item. But first we want to get the packages for the SQL Server. We go to the solution part here and right click on it. Then go to Manage NuGet Packages and go to Browse and search for SQL. We will find here Microsoft.data.SQL client. We right click on it and select this and install, apply, accept. Now we have installed the Microsoft.data.SQL client. We go back to our code and add the directive using system.data.SQL client. Now we are ready to write the code of each item, but we want to change the name of the button to here. Button 2 is the search button. If you write here, he will take us to button 2. So if you want to change the name of it, we can right click on it and select rename. Let's make it search button search. So first we want, whenever we click search and the text box is empty, to return null or nothing. So we can check it by using if string dot is null or empty. We want the name of the text box we have. We can go to design and change the name of the text box. Let's make it just product name. Now we can pass the text box name, product name dot text. Return null. Now if we click search and there is nothing or empty, it will do nothing. Now to make a SQL command, we need to open a connection with the SQL server and we want a query. So first let's make a connection. Connection. Let's make it con equal new SQL connection. And we need to give the name of the connection, but let's store it in a string. Connection string equal. To get the connection string, we go here to SQL server and we choose the database we use. Then we will find connection string here. We can copy this, paste it here. Semicolon, and we delete the spaces between trust server certificate. Connection string. Okay. We want to open this connection. And we want to make a query. Let's name it query. Now we can make the SQL command. SQL command. let's name it cmd equal new SQL command, and we give the query and the connection string. Now we want to make this query and store it in SQL data reader. SQL data reader. Let's name it reader equal, our command name is cmd dot execute Now we want, if the reader got data, to display it, and if there's no return, to display out of the stack. If reader read text product name dot text equal reader price to string and to display the image we want to change it to byte and use memory stream to display it. So byte our image equal reader image, and we want to store it as a byte array. Now using memory stream, stream sm equal new memory stream, and we give it our image. Picture box 1 dot image equal image dot from stream sm. Else message box dot show dot show out of the stack. stock. Alert. This is the title. And message box buttons. OK. Message box icon dot warning. And we want to clear the price and the image. Text product price let's see where is the error. Text product price. And here we want to change price also. Text product price dot clear. And picture box 1 dot image equal null. Then we close the connection and the reader. Dot close. And connection dot close also. Now we can try our button. MacBook. Out of the stock. Okay. Is this capital? There is no products, so we can add one. New query. We can paste this. We can try it again. MacBook. Search. Now it's working. And also we want, when we click buy, to add a new order to the order table. So we can go here and change this to the name of this. Text account ID. Enter. And this, let's name it Y. So for this bottom pie, We want also to make a connection string, so we can just copy it from the first button. And also we want to make a query to insert in the order table the order price and the product name, and also the status of the order and the date of this order. So we want to make two variables, one for the status and date time, current date equal date time now, and string query equal insert into order price status customer ID and date, values order price, we get it from text dot product price dot text, and we have status from status variable, and we have customer ID from, did we give the customer ID a name? Yes. Okay. Text. Okay, dot text. And last one is date. We have current date variable. Okay. Semicolon. Now we want to make SQL command. cmd equal new SQL command, and we give it query and con. Now we want to execute the query. We will use cmd dot execute non-query, and this function gives values of the rows affected in the database, so we can store it in integer. Let's make it rows affected, So we want to check if rows affected bigger than 0 to display added successfully, else we want to show an error message. Affected bigger than 0. Message box to show. Added successfully. Success. And message box icon dot information. Else we want to do the same. Failed. Error. Then we want to close the connection. Close. We didn't include any protection from SQL injection or checks to make it simple. Let's try it. Mac book search. Okay, let's make it 2. Why? Near the O keyword order, we should put order in square brackets. Order price. Let's try it again. Okay, 2 by added successfully. So this is all for this video. I hope you enjoyed it, and if you have any doubts you can leave a comment in the comment section.